Good afternoon, friends. In last lecture we have seen what do you mean by implicit function as well as your explicit function. So in today's lecture we will see the condition for your maxima as well as minima. So I think this topic is not new for you. So in maybe in 11th and 12th you will learn what do you mean by your maximum point, what do you mean by your minimum point. So as you know, the derivative is play an important role to find out the maxima and minima point of a given function. Okay, so suppose you have given any function just like this one. Okay, so in this case this is your x, f of x function. So this is independent variable and this is just like your f of x. And here you will get one particular point, here you will get also one particular point. So the given point we will call, this is nothing but your maximum point, this is called as your minimum point. Okay, so this case probably you have heard. So in some function there is a no maximum or minimum point, just like y is equal to your x cube. So it is the nature of the graph, it is just like this one. Okay, so there is a no sudden turning point. Okay, so the derivative means what? At that particular point, so this is df by dx equal to 0 at one particular point. Okay, so that is nothing but your stationary point. So we will come to that particular point. So this function will be increased and there is a no sudden turning point. So there is a no maxima and minimum point in case of y is equal to. So this function does not relate to any maxima or minimum point. Second example, suppose e raised to x. Okay, so that graph is going just like this one. So this is e raised to x graph. Okay, this is x and this is your function of e raised to xy. Suppose log of this one. So the given graph. So there is no maximum and minimum point in such type of a graph. So sometime probably you have heard the word is your local maxima and local minima. Okay. So your function y is equal to, or f of x, I can write, this is f of x, is your sine of x. So what is the graph of that one? So as you know, the sin x graph in between this one. So here is plus 1, here is your minus 1. So always lie between, this is minus 1 to 1. So maximum value of a given function, is what? 1. So f of x equal to 1. So at any value, if you see this point, this point, this point, this point, so the maximum value of that function is 1 and the minimum value is minus 1. Okay, so such a type is called, you can say that this is absolute, okay, maxima or your absolute minima point. Okay, sometime you can call this is your local maxima and local minima point. Okay, so in this case this is constant throughout. Okay, and the function value is not greater than this particular value. If your value is greater than this value, then we can't say this is your absolute maxima point. Okay, is that clear? So that thing you have to remember here. Then second thing, your local maxima. Suppose you are given any function. Okay, so now please remember over here, so that you know a little bit. Okay, so this is your local minima, this is your maximum, this is your again minimum. So this is minima point, this is your maximum. But in case of your fx, this fx value is larger, this is also maximum. Okay, this is also maximum point, this is minimum point, this is minimum point, this is minimum point. But sometime the value of your function, means the maximum point value, is less than the minimum point value. Means this minimum value, somewhere suppose this is -1 and you will get this is -2. So how much is the maximum value of that particular function? This is -2. But here you will get a local maxima is -1. So this value is greater than this one. Okay, so -1 is greater than your -2, means sometime your value of a function, means at the maximum point, is less than your minimum point of that particular function. So that time we can use the word is your local maxima and local minima. Okay, suppose in this graph I have to find out the maxima, absolute maximum. So this is the absolute maximum value. Where is the lowest minimum? This is the absolute minimum value. Okay, the lowest value of that particular function. So that is the case. Okay, so we will start. What do you mean by your law? So as you know, the derivative will be defined your maxima and minimum point. So the first condition is the derivative of a function is 0 at point, at some point or at a point. So what do you mean by this one? So this is your graph. So this is my A, B, C, here is suppose Q, here is X. So this is X and this is f of X. Okay, so the derivative of a function is 0 at a point, and the given point is called as your stationary point. Stationary point. Okay, so where is the stationary point? So derivative of a function is 0, means suppose you have taken this B point, suppose you have taken the Q point, suppose you have taken S point, and if you find out the derivative of that particular function, and that goes to 0. Okay, so this is your I am talking about the derivative. This is your function. Okay, so derivative means this is df by dx is equal to your 0. Derivative of that particular function at that point is called as your stationary point. So what do you mean by at that point? So this is nothing but the point is decided by your tangent line. Yes. So this is nothing but, suppose we have to give a tangent to that particular point. So suppose we will give a tangent here, here, here. So in the drastic nature of the curve is just like horizontal. So I will give a tangent over here. In this case I will give a tangent over here. So here the point B is nothing but tangent to the given curve at that point, and that point is nothing but your stationary point. Okay, now the stationary point is categorized into the 3 cases. So first thing, the derivative. So this is must. Derivative of the function is 0 at one point, that is called as your stationary point. So the stationary point is considered into the 3 cases. One is your maxima, minima. So in all the cases, at B point your first derivative is 0, at Q point derivative is also 0, and at S point derivative. So but we don't know which point is maxima, which point is either B is minima or maxima, either Q is minima or maxima, or S is maxima or minima. So how we can decide that particular case, that we want to find out. So first, the derivative of that particular function should be 0. That is my first case. Then if you want to find out, suppose I will see this particular graph carefully. Okay, from the B point, suppose I will go in this direction or in this direction. The function is increased. If you go away from point B, the function is increases in both the sides. Function is increases in both the sides. So from B, suppose I will go into the, so this is x value, something x is equal to 2. So suppose I will go x value is less than 2. So the function is also increases. Suppose x is greater than 2, your function is also, so fx is increases and fx is also increases from your point B. Okay, so in both the direction your function is increases. So such a point is called as your minima point. Minima. So point B is called as your minima. Now whereas in case of the point Q, if I am going in the direction, okay, suppose x value, so in both the direction your function it decreases. See fx value in both the directions. Suppose I will go to the left value of a Q, means x is, suppose this value is something, x is equal to suppose 10. So x is less than 10. So in that case function is also decreases. I am talking about function, not derivative. The function it decreases. If x value is greater than 10, your function is also decreases. Function it decreases means the given point is your maxima point. Maxima point. Okay. And suppose your function is neither, means one side increase, one side decrease, suppose. So this is nothing but your saddle point. So in the direction there will be no change in case of your S. So that is your saddle point or point of inflection. So that is the case. So in this case, this is regarding to your function, but you want to find out using the second derivative. Here we have taken the first derivative and that is equal to your 0. Okay, so here you will get the values x1, x2 and so on. That is, first take the derivative of that function, equate the given derivative equal to 0. So here you will get the points. Okay, once you will get a tangent point, put that value in that particular equation. Okay, and find out the second derivative of that function d2f, because the first derivative is 0 and you want to find out the maxima minima point using mathematical way. Okay, so in mathematical way, so the first derivative equal to 0. So from here you will get the point value of your x, you will get from here x1, x2, something, whatever that polynomial. Okay, then find out the second derivative f2 d2f by dx square. Okay, so that will be decide your function, means the second derivative of that particular function might be increasing after putting the values, or less than 0 or equal to 0. Okay, so this is one case is there. So f2 d2f by dx square is your greater than 0. Okay, so first derivative is 0. So suppose a point B is minimum, but we don't know using that particular graph. So what I will do, I will take the first derivative of that particular function. Okay, I know the value of x, I'll again go to the second order derivative. So here please remember, a given function should be continuous and differentiable. Okay, then I can go to the second order differential equation. The second order differential is greater than 0 after putting a value of your x, and it is suppose positive, then this is condition for your minima point. Don't confuse with the word. This is minima point. Condition for minima means their second derivative of that function is greater than 0. If the second derivative is less than 0, means d2f by dx square is less than 0, so that case the point is your minima. So this is condition for your minima case, and your d2f by dx square, so this is nothing but your saddle point or your stationary point. So here is no maxima or minima point in this particular case. So maxima and minima you can get from this particular function. So in a simple way you can find out maxima or minima point condition. Okay, so here we will take some graph. So in this case, see, we'll see in terms of slope. Now this is fx, this is x. Suppose I'll find out a slope of this particular line. Slope of this particular line is negative. Okay, so this is what? df by dx. You are finding out slope of this particular curve, df by dx. So in this case, this is your negative. If I will find out, so I know the slope here is 0. In this case, the slope is positive. Here is negative. So you are going from negative to positive. Your function is going from negative to positive. Then your point is minima. Three ways you can find out a given things. Okay, so first I have told in terms of function, the function value is greater, okay, increasing in both the direction, so that is your minima point. Second way, df by dx, if you find out, and the given function means whatever that derivative is running from, suppose negative 0 to positive. Okay, so x is increasing in this particular direction, so here is slope is negative, here is 0, here is your positive. So it is going from negative, slope is negative to positive, so the point is minimum point. Okay, just like this curve, suppose I have given this one, so it is rotate, this chalk is rotate here, and at one particular point it is at a steady, that is nothing but yours. So same, you can many times you will use the word is potential energy is minimum. Okay, so that is nothing but this particular point. Okay, so in this case, now this is point Q. See, x increasing x direction, here the slope is positive. Okay, slope, I am talking about the slope is positive, so this is df by your dx, this is positive, here is 0, and in this direction it is negative. Slope of this line is always negative, so here you will get a negative sign. So positive to your negative, such a point is called as your maximum point. Maximum point. So this is the condition from your derivative of that particular function. So negative, positive to your negative. In this case, it is just like stationary. So this everything, suppose you will find out d to f. So the second derivative is also 0. So there is no positive or negative value. So the given point is your saddle or stationary point. Okay. So this is about your condition for your maxima and minima point. The first thing you should remember, derivative will be decide your function is maxima or minima point. So derivative, first condition is the derivative of the function is 0 at that point. This is your stationary point. So please remember all the point b, q and s. So first derivative of that particular function is 0. Now I am to decide this point or this point is either maxima or minima. So I will go for that function. So if I will go from b point to here or here, the function is increases. So I decided this b point is my minima point. So from the q point, both the direction your function is decreases. Function is decreases means this is your maxima point, and here neither increasing or decreasing. Second case is what? Suppose I will find out a derivative of that particular function. Okay, so derivative is, this is f. So slope of this line, and it is changing from negative, 0 and positive. So that is nothing but your minima point. Suppose your derivative of that particular function positive to the negative, then this is your maxima point, and equal to 0 means your saddle point. So this is the condition for your maxima and your minima point. Okay. So many times they will ask the one example. So either for 1 mark question they can state the condition for maxima or minima point or the saddle point. So you should know the condition in terms of that particular function. Okay. So in terms of second order, so that you have to mention over here. Okay. So I will take one problem so you will understood this one. So last time you have taken the example of this one. So I will go little bit depth inside this one. So this is x square plus y square equal to your 1. So from here I can, this is equation of circle. Okay. So this is equation of circle having the radius is 1. This is your x suppose, and this is my y. So y is equal to what? Plus or minus under root of 1 minus x square. Okay. So here is also 1 everywhere. Now in this case I can take the first derivative of this particular function. So I will take the first y is equal to under root of 1 minus your x square. So dy by dx is what? This is nothing but what? 1 minus x square raised to half. So this is half is going to come over here. So 1 minus x square raised to half minus 1 into derivative of this is minus x square. So this is minus twice of x. So this 2 get cancelled. So what will get here? This is minus x upon, this is half minus 1 is minus half. So it is coming down. So you will get 1 minus x square raised to half. Okay. Then I will go again to the your second order, d2y by your d square dx square. Okay. So this is nothing but I will apply the chain rule over here. Okay. Or two functions. So this is x suppose. So this is 1 over 1 minus x raised to half. This minus x as it is, and derivative of this is 1 upon this particular value. So that derivative is how much? This is coming up. So this is just like minus half. Okay. 1 minus x square raised to, this is minus half minus 1 into derivative of minus, so this is minus 2y6. Okay. So what is remaining over here? So this is minus 1 upon x square raised to half minus this 2 get cancelled, minus minus plus, and again this minus x and x is x square. So this is x square upon, this is what? 1 minus x square minus 1 half and minus 1. So minus 3 by 2. So when it is coming down, so minus 1 minus x square raised to 3 by 2. Okay. So we'll make the denominator is same. So I'll multiply this with 1 minus x square. So what we'll get over here, this is 1 minus your x square, this minus sign, and denominator is how much? This is 1 minus x square raised to 3 by 2. So how much is the value? This is minus 1. So this is minus 1 plus x square. This get cancelled. So you'll get 1 divided by 1 minus x square raised to 3 by 2. Okay. So I'll directly write down the step over here. So when you have taken the second differentiation of this one, function y, so you'll get this value. So that value I'll write over here directly. So due to the shortage of space. So this is minus 1 divided by 1 minus x square raised to 3 by 2. Yes. Now here again I will take y is equal to minus 1 minus x square. This is very interesting. Later on you can see. So minus under root of 1 minus x square. When I will take a derivative of that one, so this is dy by dx. So this is simple. You will get, this is minus half, okay, 1 minus x square raised to half minus 1 into, this is minus twice x, minus minus plus 2 to get cancelled. So you will get value x over, this is 1 minus x square raised to half. Okay. And when you plot or means find out the value of d2y by dx square, so you will get 1 divided by, so you can try at home. So you will get the value minus 1 upon this particular value. Okay. Now from this equation, the first derivative of that particular function is 0. Okay. So this is equal to 0. So please remember, so what I will get for this one? So I will get d2y by dx square is equal to 1 divided by 1 minus x square raised to 3 by 2. This is what? Y is equal to minus x square. Okay. So this is the case. Now interestingly, this is equal to 0. I want to find out which are this particular point. Okay. So this first derivative of that particular function, this is equal to 0. This is coming over here and you will get x equal to 0. Okay. So x is equal to 0 means here the tangent. X equal to 0. So suppose I will plot this x equal to 0. So x equal to 0, we have two values. See, this is the graph y is equal to under root of 1 minus x square. This is positive half. This negative half is indicate what? This is y is equal to minus 1 upon 1 minus x square. Okay. So if you plot a different graph, the nature is just like this one for this. And for positive case, I will get only this much. Positive half for this one, this is minus under root of, so this is the case, y is equal to minus 1 minus x square. Now you have find out what? Dy by dx. Dy by dx you will get value minus x divided by, so this value is what? Minus x divided by y. Y's value is what? Under root of 1 minus x square. 1 minus x square means y value. So that we have taken here. So the graph is what? In this case, I will get a such type of graph. Minus x divided by y. In this case, the graph is here. Suppose I will find out dy by dx. So this is my dy by dx and this is my x. Okay. This is my y, this is my y, this is my x. So in this case, my dy by dx is what? Minus x divided by y. here dy by dx, so value is what? X divided by y. So the nature of that curve is just like this. Okay, so you will get the 2 points. This is 1 point and this is your another point. So we want to find out where is the maxima and where is, because interestingly you will get x is equal to 0 for both the things. 1 point is here, 1 point is here. So we have to check your second condition. Second condition, x is equal to 0. Okay, so when I will put that x equal to 0 in this case, so this is d2y by your dx square is equal to minus 1 divided by 1 minus 0 square raised to 3 by 2. Okay, so this is nothing but minus 1, so which is less than 0. Okay, less than 0. Now I will increase the value of x, negative or positive. So what kind of a nature you will get? So I can write over here. So this value is negative. So in this case, when you put, so this I will get a negative. Whereas in this case, suppose I will put x is equal to 0. X equal to 0. So in this case, 1 divided by, so I will get a positive. Here, in this case, you will get a negative second order. In this case, you will get a positive. So the nature of the graph is what? X is equal to 0, you will get a minus 1 value here. Okay, so that minus 1 value, so you will get such a type of graph. Okay, and now you have taken y is equal to minus 1 under root of 1 minus x square. So in this case, suppose your slope C, it is coming here and then going over here. Okay, in this case, find out the slope. Okay, so it is positive 1 and you will get such type. So here, this is y equal to your 1, y, not y, this is your d2y by your dx square, this is your x. Okay, so this is nothing but what? Your x, and this point, so here d2y by dx square is greater than 0 and here d2y by dx square is less than 0. Okay, so in case of circle, suppose we have given the example, so no one go to the detail over here. X square plus y square equal to 1, this is the condition. Then we can find out that function it depend on x. Then there is two values of y, so y is equal to under root of 1 minus x square. You plot that value and I will get a second curve. So this is your maxima condition, this is your minimum condition. Okay, sorry, this is your minimum point and this is your maxima point. So this nature for that particular curve is your minima and your as well as your maximum case. Okay, so first thing you should remember, the derivative is useful for finding out the maxima as well as your minima point. Okay, so we'll take one example so you'll understood. So in exam they will ask the one problem related, find the position and nature of a stationary point. Find the nature, position and nature, find the position and nature of a stationary point for the function fx equal to, this is x cube minus 3x plus 3. So many times such type of problem they can ask for 5 marks or 4 marks also. So 1 mark is a condition for maximum or minimum case. So find the position and nature of a stationary point. Stationary point means for derivative is 0. So what I will do, I will take the condition, given condition is what? Stationary point. So df divided by dx. So that is nothing but 3x square minus 3. Okay. So this is equal to 0. So 3x square minus your 3. So when you take 3 common, 3 is going here. So x square minus 1 equal to your 0. So x equal to 1. Okay. So plus or minus 1. So just it is going over here, x square equal to 1, and then you will get x is equal to plus or minus 1. Now we have 2 points, so we have to check that particular condition. Okay. So I will go to the second order partial differentiation. So d2f by your dx square. So how much is the differentiation of this one? This is 6x. Okay. Now put x equal to 1. So what is the value? d2f by dx square at x equal to 1. So that is nothing but what? 6 into 1, that is 6, which is greater than 0. When put x equal to minus 1. Minus 1. So over here, so d2f by dx square, which is equal to 6 into minus 1, so that is minus 6. So you will get this is less than 0. So we know the second order derivative is greater than 0. Greater than 0 means x equal to 1 is minima point, because the second order derivative is greater than 0, and here this is less than, then this is x equal to minus 1 is maxima point. Okay. So this will be the case, maxima as well as your minima point. Okay. So such type of example they can ask in examination. So this is the